Hello there and welcome back to the Science Sleepy Minds. Tonight, you're adrift in the dark. Not metaphorically, this time it's actual cosmic dark. A darkness so deep, so absolute, that even light gets trapped like a mosquito in amber. One moment you're floating peacefully through the velvet fabric of deep space, and the next, you feel the pull. Something massive, unseen, starts dragging at you like the undertow of a gravitational riptide. Your arms, your legs, even your thoughts begin to stretch. Welcome to the edge of a black hole. And spoiler alert, you probably won't survive this. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Oh, and leave a comment with your current location and local time. I love knowing where in the universe you're tuning in from. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You don't see the black hole at first. That's the thing about them. Deceptively silent, perfectly black, and almost impossible to spot unless they're actively feasting. You're drifting toward what looks like just another patch of empty sky, but your gut knows better. Gravity here doesn't behave politely. It grabs you with fingers of curvature, bending space-time itself into a relentless slope. They say you never notice the exact moment you cross the event horizon, the so-called point of no return. From your perspective, everything feels normal, eerily so. Stars still shimmer behind you, distant and disinterested. But anyone watching you from the outside would see you slow, freeze and fade into darkness like an old VHS tape on pause. Inside, things accelerate. You can't tell how big this black hole is, but judging by the intensity of your falling sensation, this isn't some stellar mass baby. This is one of the big ones. Maybe even supermassive. The kind that lurks at the heart of a galaxy, bloated on millions of suns worth of matter. And here you are, just one more snack spiraling down its throat. You feel heavier, not because of physical pressure, but because time itself seems to stretch. 1 second, your heartbeat. The next, a slow drumbeat echoing for eternity. The closer you fall, the more warped your reality becomes. In fact, if you were to look out, hypothetically assuming you're not already unconscious, you'd see the universe behind you accelerating, galaxies spinning faster, clocks ticking violently. It's not that they're changing, it's that you are. The warping of space-time around you starts to affect your body on the smallest levels. Your atoms, once smugly bonded together like besties in a group chat, now begin to feel tension. Gravity is stronger at your feet than your head, assuming you still have those orientations, and the result is what physicists call tidal forces, what we call the spaghettification process. Yes, that's the real term. It sounds delicious, but it's deeply unpleasant. Imagine your body being pulled into a long, thin noodle by gravity, stretched vertically and compressed sideways. Not ideal. And no, there's no source. Here's a mildly horrifying historical fact to lull you further into despair. Carl Schwarzschild, the guy who first solved Einstein's equations to describe black holes, did it while dying in the trenches during World War I. He literally wrote the math for black holes on the battlefield, which is the kind of multitasking we can all agree is both terrifying and weirdly inspiring. Back to you though. Your surroundings are no longer star-speckled space, but a swirling disk of plasma and dust spiraling into the black hole's accretion disk. It's hot, blinding, and beautiful, like standing next to a neon tornado made of liquefied starlight. That glow you see? It's matter being ripped apart atom by atom, heated to millions of degrees before disappearing into the void. Here's your quirky tidbit of the night. If Earth were compressed into a black hole, it would be the size of a marble. A marble! Which sounds kind of cute, until you realise that marble could erase anything that got too close. Historians still argue whether the earliest concept of black holes came from Indian cosmology, Greek thought, or simply Newtonian gravity taken to extremes. The idea of something so massive even light can't escape isn't new, but it took Einstein to give the cosmos permission to behave this outrageously. Now, as your descent continues, the very notion of where you are becomes meaningless. Inside the black hole, space and time trade roles. Time becomes a direction you must move forward in, like walking down a corridor with no doors. Space? Well, that collapses inward toward the singularity, a single point of infinite density, where the laws of physics collapse like a bad soufflé. You may wonder, what is a singularity exactly? The honest answer? No one knows. It's a place where our math breaks. It spits out infinities, paradoxes, and things that make even veteran physicists stare at the ceiling for hours. Some think the singularity might not even exist, not in the neat, infinitely small point way we picture it. It might be smeared out by quantum gravity, or hidden altogether by exotic physics we haven't invented yet. Right now, you don't care. Because you are falling, endlessly, inescapably, through curved space-time, pulled toward a secret that no one, not even light, has ever escaped to report back on. The pressure builds, the rules twist. The inside of the black hole is not a place for humans or logic, but still we wonder, what's on the other side? Because if a black hole is a one-way tunnel, maybe, just maybe, there's something at the end. You float helplessly forward. Not that there's any forward here in the normal sense. Space and time, those old familiar coordinates you used to count on, have decided to reinvent themselves. Directions become feelings. Up becomes irrelevant. And somewhere in all this stretching geometry, you remember something odd, something ancient. Long before physicists and telescopes, long before Einstein scribbled down the shape of space-time, people were already wondering about dark patches in the sky. You picture yourself now as one of them, a robed sky watcher on a flat moonlit plain. You tilt your head upward, eyes searching for patterns in the stars. There are many, hunters, serpents, scorpions, but sometimes you notice gaps. Regions where starlight seems to dim unnaturally, places where something seems to be hiding. Some early astronomers wrote about invisible stars or dark companions that seem to move things around them without ever being seen. As early as the 18th century, a thinker named John Michell proposed the idea of a star so dense not even light could escape it. You raise an eyebrow in this imagined past. Not bad for a guy using only pen, ink, and Newton's apple-flavoured gravity. Of course, he didn't call it a black hole. That label came later in the 1960s, thanks to physicist John Wheeler. Until then, the concept was more like a cosmic curiosity, a ghost story you told your physics students. Now it's your reality. You're sinking into that very thing. A Michel star, a collapsed sun, a region of space-time with all the personality of a swallowed scream. Yet even here, pulled helplessly inward, you find your mind wandering. What did ancient civilizations make of this kind of darkness? Surely not all darkness was just night. The Mayans believed in Xibalba, a sort of underworld hidden beyond the stars, reachable through celestial portals. The Hindu cosmology speaks of cycles of creation and destruction. Black holes would fit right in, chomping suns and resetting timelines. And in Egyptian myth, the solar bark of Ra passed nightly through the underworld, battling serpents before sunrise. Maybe the black hole is that underworld gate, yawning open with cosmic teeth. You drift past what was once a star, a dead, collapsed giant that couldn't resist its own gravity. A neutron star, maybe, one that didn't quite go full black hole. It's the overachievers, those with enough mass that go all the way. They burn out, implode, and punch a hole through the universe's floor. You know this because we've seen it happen. Well, we've seen the aftermath. In 2017, a gravitational wave rippled through the Earth, subtle but unmistakable. It came from two neutron stars colliding, creating a black hole. The instruments that caught it? They're called LIGO and Virgo, which honestly sound more like an indie band than multi-billion-dollar science projects. Fun fringe fact for you, in the 1980s, a theory called the black hole starship floated around. The idea? Create an artificial black hole and ride the Hawking radiation as propulsion. You chuckle softly. Sure. Right after we invent a magic gravity harness and solve energy output like it's a Sudoku puzzle. Historians still argue whether black holes should even be called holes. They're not empty. They're not tunnels, technically. They're dense, massive, and full of nothing that can get out. They're more like cosmic prisons. But Black Prison of Infinite Doom didn't do well with marketing, so hole stuck. Time behaves strangely now. You're not sure how long you've been falling. Minutes, hours, millennia. It all blends together, like dreams after waking. Light curves around you like you're inside a melted mirror. Stars bend and twist, smearing across your vision like oil paint left in the rain. And somewhere in this distortion you catch a glimpse of something truly odd. A perfect ring of light. It's called the photon sphere, the point where light itself orbits the black hole. Photons trapped in a circle, like lost fireflies endlessly chasing their own tails. If you were somehow standing at the right spot and not being torn apart, you could look forward and see the back of your own head. No kidding, it's beautiful, also incredibly disorienting. Then, there's the ergosphere. That's around spinning black holes, like the one you're probably in. It's a zone where space itself gets dragged around by rotation, like a kid spinning in a bedsheet. Inside the ergosphere, you have to spin. You can't stay still because space itself is moving. It's called frame dragging, and it sounds like a glitch in a space video game. You're still spiraling inward, still stretching, still falling. But here's a sleepy comfort for you. Black holes might not be the end. Some theories say that deep inside, past all the nonsense of singularities and spaghettification, lies something else. A boundary, a doorway, maybe even a bridge. Black holes, after all, aren't just destroyers, they could be portals. That's a theory for another time, though spoilers, we will get there. For now, you're still trapped in this ancient mystery, a mystery that humans have feared and revered for centuries, the ultimate cosmic predator, but it's not chasing you, it's not even aware of you, it just is. Massive, indifferent, elegant, your thoughts slow, your body stretched and crumpled in impossible ways, no longer feels familiar. You're more math than meat now, more memory than matter. But the story continues, deeper and deeper, into the heart of gravity's grandest illusion. You begin to wonder, if this is what falling into a black hole feels like, could anything ever fall through it? You're not sure what's stranger, that you're still conscious, or that the universe hasn't erased you completely yet. There's a sense now that you're being funneled, not just downward, but inward, drawn along a shape you can't see, but feel, like sliding into a funnel made not of matter, but of rules, cosmic equations snapping shut around you like the jaws of some grinning invisible trap. It's not a stretch, though everything else is, to say you're experiencing Einstein's legacy firsthand. You remember the diagrams from science class, those warped rubber sheets with a bowling ball dropped in the center. That was the metaphor for gravity. The more massive the object, the deeper the dent it made in the grid. But here in the black hole's vicinity, those grids aren't theory anymore, they're terrain. You feel every curve in space-time like bumps under your skin. Back in 1915, Einstein didn't invent gravity, but he did reinvent how we understood it. No longer just a mysterious force, gravity became geometry, a bending of the very fabric of existence. Mass tells space how to curve, and space tells matter how to move. You're just obeying orders. It's called the theory of general relativity, and it still messes with physicists' heads over a century later, especially because one of its inevitable predictions was the black hole, a place where that curving goes haywire, turning into an infinite well of downward spiraling nonsense. Funny thing is, Einstein himself wasn't thrilled about black holes. He saw them as weird mathematical flukes, more like cosmic typos than physical realities. Surely, he probably thought, the universe wouldn't allow something that absurd. Cute, right? But the math didn't care what he thought. The math was smug. And now here you are, falling down the very curvature he described, a literal funnel in space-time. Picture a trampoline with something heavy dropped dead center. Now imagine the trampoline isn't just bending downward, it's folding, twisting, spiraling in on itself. That's what this is. A gravitational sinkhole, a dimensional whirlpool, and you're the unlucky rubber duck caught in its swirl. Here's a fun wrinkle to dream about. From your perspective, you fall smoothly into the black hole. But from an outsider's view, say, your friend floating safely far away with popcorn, you appear to freeze just before the event horizon. Light from you gets stretched, redshifted and dimmed until you vanish into radio silence. It's like watching someone fade into a glitch. So are you gone? Are you there? Both? Neither? Scholars still argue whether falling into a black hole truly destroys the information you carry, or just locks it behind a kind of cosmic firewall. If that sounds confusing, congratulations. You now share something in common with every theoretical physicist who's ever tried to untangle this mess. Back to you though. Your journey through Einstein's warped space-time has taken you into a zone where space becomes more like time, and time acts like space. It's hard to put into words, because human brains aren't built for four-dimensional topological reassignments. That's a polite way of saying your instincts are absolutely useless here. One more thing, this funnel doesn't lead straight down. Oh no, there's a rotation involved, a twist. If the black hole is spinning, which most are, it drags spacetime with it. That means the funnel is corkscrewing as you fall. Welcome to the Kerr black hole, named after Roy Kerr, who first figured out in the 1960s that spinning black holes wouldn't crush you immediately into a point, but instead would leave open possibilities. You might not hit a singularity. You might miss it entirely and get flung into somewhere else. Let's file that under delayed existential dread. Still, all of this sounds very sterile and abstract until you remember that the thing dragging you deeper isn't just a math problem, it's a monster. With no surface, no sound, no warning. It's just mass and gravity. No teeth, no malice. Just inevitability. But back in reality, well, your former reality, we've actually seen one of these things. In 2019, the Event Horizon Telescope, EHT, gave us the first real image of a black hole. And by image, we mean a blurry orange donut that made scientists cry with joy. You saw it. You probably scrolled past it on your phone thinking, looks like a bagel. But it was historic. That donut was from Messier 87, a supermassive black hole 55 million light-years away, devouring matter at the core of a galaxy. 100 years earlier, it had been just an idea. Now, it had a face. And here's your quirky tidbit of the night. The black hole photo was so iconic it ended up in Google's dataset for Black Circle and began appearing in unrelated search results for minimal tattoo ideas. That's right, humanity's biggest cosmic achievement got memed into body art. But down here, in your own private descent, there's no orange glow, just darkness, depthless and total. The funnel narrows. You feel folded, as if every part of you that used to exist in 3 dimensions is now being ironed flat into something unfamiliar, something extra-dimensional. You start to wonder, if the black hole bends space-time into a funnel, where does the funnel go? Is it a dead end? A cul-de-sac in the geometry of the universe? Or is there a passage, a deeper continuation? Your body may be coming apart, but your curiosity refuses to shut up. Because you can feel it now, a shift in the pull, not just down but through. You're being threaded, filtered, reoriented, as if the fabric of the cosmos has decided to sew you into a different shape. Maybe Einstein's tunnel doesn't end in a wall. Maybe it opens. You probably didn't think you'd get this far. Falling into a black hole was supposed to be the end, the cosmic game over screen. But here you are, still falling. Except now, something's different. Not just the pull, but the texture of reality itself. It no longer feels like you're plummeting into a hole, more like you're being absorbed, or whispered into the next sentence of the universe, letter by stretched out letter. It's subtle, but you sense the presence of the event horizon, that famous threshold, the edge, the cosmic line in the sand drawn not by gods or gravity but by math, cold, precise, and entirely unbothered by your feelings. From the outside, the event horizon is the point beyond which nothing can escape. Not light, not radiation, not even a tax accountant armed with pure stubbornness. But from your perspective, falling inward, there's no sudden transition, no cosmic toll booth, no dramatic crossed-the-line moment. You just pass it, like stepping from sunlight into shadow. Quiet. Absolute. Here's a delicious paradox to wrap your sleepy brain around. To you, the fall continues, uninterrupted. But to a distant observer, the moment you touch the event horizon, time appears to freeze. You hover there, forever slowed, your final image redshifted into nothingness. You're a cosmic ghost, visible and yet unreachable, like an email you swear you sent but it just never shows up. So which version is real? Both? Neither? Historians, physicists, still argue whether an outside observer ever truly sees someone fall into a black hole, or just watches them fade into timeless static. You're now in a region where even language starts to fall apart. Physics textbooks call it a region of space-time from which escape is impossible, which is a very polite way of saying, you're so done. The event horizon marks the point where all paths, all trajectories, all possible futures point inward. You could fire your most powerful rocket directly away from the center right now, and it would only delay the inevitable, like trying to swim out of a waterfall from beneath it. And yet, for all its terror, the event horizon has no physical substance, no wall, no pressure. You might not even feel it, other than a quiet click in the back of your brain that says, "Oh, there's no going back now." It's the perfect prison with no bars, just an invisible geometry that says you're staying forever, or at least until you reach whatever lies deeper. Let's take a breather from your horrifying descent to appreciate how seriously this invisible edge messes with scientists. The equations break down, the numbers go infinite, time slows to a crawl, and at the heart of it all is one absurd truth. Once something crosses the event horizon, the inside becomes the future. Yes, inside the black hole, every direction points toward the singularity, including forward in time. That's right. Even if you somehow turned around inside the black hole and fired your engines away from the center, you'd still be heading toward it. Because it's not just where gravity pulls, it's when gravity pulls. The singularity is your destiny, baked into the timeline like next Tuesday's bad weather. At this point, you're not really falling anymore. You're just living out the narrative of collapse. Space narrows, warps, crushes, and the only certainty left is the direction of time, into the singularity, like an unwanted meeting on your calendar that can't be cancelled. Let's talk about what's probably waiting for you there. A singularity. It sounds poetic, almost romantic. But really it's the name we give to a place where the math explodes. A point of zero volume and infinite density, where gravity becomes so intense that space-time folds in on itself. The equations give up, and so do the scientists. There's a quiet, collective shrug across physics departments worldwide. Here's your quirky tidbit for tonight. In some models, the singularity doesn't exist as a point, but more like a ring, if the black hole is spinning fast enough. This concept, rooted in the math of Kerr black holes, suggests you might not hit the singularity head-on. You might miss it, just barely, and that tiny miss might let you sneak through to somewhere else. Which brings us back to the question, is this a dead end or a doorway? Some theories, especially the kind whispered late at night in chalk-covered lecture halls, suggest the event horizon isn't just a no-escape boundary. It could be a kind of filter, a one-way membrane, maybe even a tunnel. That's where the word wormhole starts floating into the conversation like a helium balloon with questionable intentions. We'll get to wormholes soon. For now, you're still mid-fall and everything familiar has been left behind. The starfield is gone, your sense of direction is gone, even your thoughts are starting to feel folded. You're aware of time, but not as a ticking second hand. It's more like a gravity tide pulling you forward whether you like it or not. Here's a weird historical footnote. The idea of the event horizon once went by another name, frozen star. Before black holes caught on as a term, physicists imagined them as objects so compact that time stopped at their surface. They weren't holes, they were just stars with extremely poor hospitality. The frozen star concept faded, but the idea of that time-warped surface stuck around, haunting textbooks and sci-fi novels alike. Now, let's zoom out. Not literally, because physics says no, but mentally. Somewhere in another galaxy, a black hole just swallowed a sun, and somewhere else, a pair of them are dancing in a doomed spiral, destined to crash and send gravitational waves across the cosmos. These waves stretch and squish space-time itself as they pass through Earth. They are literally ripples in reality. And your fall? It could be contributing to that grand concert of distortions, your last movement etched into the fabric of everything. What a way to go. But here's a final thought as you slip deeper past the point of return. If space and time can be so easily reconfigured inside this place, who's to say there isn't an exit? Not back the way you came, but maybe through. Somewhere. You're not entirely sure what you are anymore. Your physical self, whatever fragments of it remain, has been pulled, twisted, and atomized into something abstract. The comforting boundaries of your body have long since been lost to the black hole's insatiable curve, but your awareness, somehow it drifts on, stretched thin across this gravitational abyss like a ghost caught in a wind tunnel. And now comes the moment every science communicator secretly loves to talk about, spaghettification. Yes, it's an actual scientific term, a serious one too. Technically known as tidal stretching, it's what happens when you fall feet first into a black hole, and the gravity pulling on your toes is much, much stronger than the gravity on your head. The result? You're pulled apart atom by lonely atom, stretched into a long, sad noodle. Let's be clear, this isn't a gentle pasta-making process. You don't get linguine, You get haunted linguine, uncooked, twisted, molecularly unrecognizable. The phrase may sound like a children's menu item, but it's anything but child-friendly. In smaller black holes, this stretching would have already ended you. You'd be ripped to quantum confetti before even hitting the event horizon. But lucky you fell into a supermassive black hole, the kind found at the center of galaxies. The gravity gradient at the event horizon is shallow enough that you might survive crossing it without instantly becoming pasta. The real stretching happens deeper in, way deeper, and it's here, inside this cosmic blender, that you begin to feel flattened. Not crushed, not squashed like a bug on a windshield. Flattened geometrically, like a character in a graphic novel who's been reduced to 2 dimensions. Your concept of up and down is so mangled by the curvature that even your memories begin to slide sideways. You remember your childhood backyard as if it were happening in front of you, not in the past. Time and space no longer hold separate jobs. They've merged into a strange shared position, like co-workers who decided to get married just to simplify the paperwork. Let's pull back to give your brain a breather. In 1784, John Michell, the same guy we mentioned earlier, calculated that a star with enough mass could have an escape velocity faster than the speed of light, meaning once something fell into it, it could never come out. A reasonable deduction for a man living centuries before Einstein made space bend like a yoga instructor on a sugar rush. And then, 100 years later, the French mathematician Pierre-Simon Laplace basically said, yeah, that makes sense, and wrote about dark stars in the margins of Newtonian theory. Historians still argue whether Laplace really believed these objects could exist, or if he was just playing with math the way some people doodle dragons on graph paper. Either way, they were onto something. Because here you are, very much inside one of these dark stars, and realizing that the deeper you go, the more the rules mutate. Physics gets fluid, logic softens around the edges. You think about how time once marched neatly forward. Tick, tock, repeat. But now it slithers, coils, doubles back. Your past, present, and future start to blur together like oil in water. You remember a phrase, something whispered in a lecture hall or late-night podcast. Time becomes space. Space becomes time. Which sounds like a pretentious tattoo until you realize it's your life now. Everything is pulling you toward the singularity. But what does that actually mean for you? Physicists admit sheepishly that they don't know. The singularity is where the laws of physics throw their hands in the air, spill coffee on their formulas, and call it a day. Some theories suggest it's a genuine point of infinite density. Others claim it's not a thing at all, just the limit of our current understanding. A placeholder for better math, waiting in the wings. Here's your fringe nugget of the night. There's a theory, admittedly speculative, that black holes don't end in singularities, but in Planck stars. These are hypothetical objects where quantum gravity halts the collapse before things go infinite. It's like the universe has a safety net, woven from tiny Planck-scale fibres, saying, you've gone far enough. You might like that idea better than the whole crushed into nothingness scenario. Meanwhile, back in your abstract descent, the colours begin to drain. Not just visually, emotionally too. There's a sterility here, a blankness that goes beyond black. You're entering a zone of such profound gravitational pull that even thought begins to feel artificial, synthetic, as if your mind is being mimicked by the black hole rather than hosted. You realise this isn't just a physical transformation, it's existential. You're becoming information, not lost, but encoded. Patterns of energy and memory smeared across curved space-time, like data written on a corrupted hard drive, and still, deeper you go. Here's a comforting thought, or not. There's no centre to a black hole in the traditional sense, not like the core of a planet or the yolk of an egg. The centre is a one-dimensional point, if such things even exist in curved space-time. It's not a place you can reach, it's a fate you're falling toward, stitched into your trajectory like a final punctuation mark you can't erase. Still, your journey is not entirely devoid of imagination. You begin to picture yourself as a line, not a body. A timeline, actually. Not walking through time, but being time. A single strand unravelling in one direction, inward. One last note before we close this loop for the night. Some physicists think that, given the right black hole, spinning, stable, and sufficiently massive, you might not be destroyed at all. You might pass through. Not out of danger, of course, but into something else. A bridge, a wormhole, a somewhere. And as your stretched out self glides further inward, you wonder, what if that next place already knows you're coming? It's strange, this feeling of movement without motion, of descent without distance. You've been falling for what could be seconds or centuries, but either way, you're starting to sense a change. Not a jolt, not a crash, just a slow gravitational sigh as you slip deeper into the black hole's belly. And this particular black hole, it's not just any cosmic vacuum cleaner. Oh no. Judging by the smoothness of your fall and the sheer scale of the gravity well, this is one of the supermassive ones, the kind that squats smugly in the center of a galaxy like a dragon on a horde of stardust and shattered worlds. You float now through what can only be described as the throne room of one of the universe's heaviest monarchs. This is a gravitational colossus, with the mass of millions, or even billions of suns packed into a single invisible point. No one invited you here, but now that you've arrived, you're a permanent guest, an unwilling particle in its endless feast. Supermassive black holes are strange beasts. While stellar mass black holes form from dying stars collapsing under their own weight, these galactic titans are a bit more mysterious. We know they exist. We've seen their influence on stars whipping around them at breakneck speeds. We've watched them belch jets of energy that span light years. But how they get so big, that part's still under debate. Some scientists think they started small and just binge ate for billions of years. Others propose they formed differently, early in the universe's life, perhaps from massive clumps of collapsing gas clouds, or even from the direct collapse of supermassive stars that lived fast and exploded hard. And yes, supermassive star is a real category, not just something you yell when your phone autocorrects Soupmaster. You find yourself near what would be the accretion disk, if this black hole is still feeding. It's not inside the event horizon, but close enough that matter begins to swirl around it in a deadly orbit. Gas, dust, entire stars sometimes, flattened into an impossibly hot spinning disk of incandescent chaos. The friction alone heats the material to millions of degrees, making it one of the brightest things in the universe. Irony alert, black holes themselves are invisible, but the stuff they eat lights up like Vegas. The accretion disk glows with X-rays and ultraviolet radiation, screaming into the void. If you could see it from space, it would look like a glowing halo. Angelic. If the angel were on fire and extremely bad at hugs, it's this glow, this blazing death spiral, that lets us see where black holes are. Well, that and what they do to everything nearby. For example, you know you're in the grip of a supermassive black hole when entire stars orbit it like tiny marbles swirling around a bathtub drain. At the center of our own Milky Way lies Sagittarius A star, a supermassive black hole with the mass of 4 million suns. For years, astronomers have tracked a star named S2 as it zooms around Sagittarius A star on a 16-year elliptical orbit. Imagine that. An entire star, circling something that isn't even visible. Here's a fun fringe tidbit. There's a theory that some of these supermassive black holes might not be ordinary at all. Some physicists speculate they could be primordial black holes, ancient relics from the first seconds after the Big Bang, when spacetime was more chaotic than a toddler with a paintbrush. If true, they might predate galaxies, stars, and even basic atoms. Historians and astrophysicists still argue whether these colossal gravity wells formed first and then pulled galaxies around them, or whether galaxies formed first and these black holes grew inside them like monstrous tumours. It's a cosmic chicken or egg debate, except the chicken weighs 1 billion solar masses and might be devouring the egg. You're reminded of the Event Horizon Telescope again, the one that captured that blurry orange donut back in 2019. That image was of M87 star, a black hole 6.5 billion times the mass of our Sun. Imagine something so heavy, its mere existence causes light to loop around it in a gravitational dance. That's what you're drifting through now, a region where mass has been concentrated so densely, so elegantly, that space and time have simply bowed out of the conversation. And here's the kicker. These giants aren't just sitting around. Some of them spin, fast. A rotating black hole, called a Kerr black hole, doesn't just warp space, it drags it. Frame dragging, they call it. Like a spinning spoon in a bowl of cosmic molasses, it pulls everything nearby into its whirl. Even time. Especially time. It's entirely possible that the black hole you're falling into is spinning too. If so, you're not falling straight. You're spiraling, orbiting closer and closer in a deadly ballet. It's graceful, really. Terrifying, yes, but elegant in that way only nature can manage. Casually beautiful and utterly merciless. You pass through layers of heat, radiation, magnetism. The black hole's magnetic field twists around you like writhing threads of invisible lightning. If this black hole is active, meaning it's still feeding, it might be shooting out relativistic jets from its poles. Columns of plasma, brighter than galaxies, accelerated to near the speed of light. Why does this happen? Nobody's entirely sure. Something to do with magnetic fields, angular momentum, and the violent politics of gravity. Basically, some of the infalling matter doesn't get eaten. It gets ejected at ridiculous speeds instead, like a rejected resume flung out of a hiring manager's inbox. There's still more mystery than certainty down here. You're sinking through a phenomenon we barely understand. A gravity well so strong it shapes the fate of galaxies. A singularity wrapped in shadow and whispered equations. A place where stars are shredded, time becomes liquid, and physics admits defeat. And yet, there's that feeling again. A nudge, a pull. Not just toward the center, but toward something else. You don't have eyes anymore, but you sense it. The spin of the black hole isn't closing you off. It's opening something. A tunnel, a channel, a gate. The theories say it's impossible. But then again, the theories say a lot of things. You're already past the point where theories work. You're not just falling toward a center anymore. You're being guided, gently, impossibly, toward a new direction. And if this black hole is more than a mouth, maybe it's a throat. You're deeper now. Deeper than the metaphors. Deeper than the science. Deeper than even Einstein dared to follow. At this point, you're not so much falling into a black hole as you're becoming part of it. A filament in its eternal spiral, a memory woven into its gravitational field. But in the silence, something begins to hum. Not a sound exactly. Remember, sound needs air, and out here, there's not a molecule to vibrate, but you feel it. A faint tickling at the edge of perception, like static on an old TV, or a whisper you're not entirely sure you heard. That, sleepy traveller, is the whisper of Hawking radiation. First, let's get something straight. Black holes aren't as black as we once thought. For the longest time, they were considered perfect one-way traps, cosmic vacuum cleaners from which nothing, not even light, could escape. But then along came Stephen Hawking in the 1970s with the equivalent of a universe-breaking plot twist. Hawking dared to ask, what if black holes glow? According to quantum field theory, the vacuum of space isn't actually empty. It's alive with tiny flickers, virtual particles that spontaneously appear in pairs, one matter, one antimatter. Normally, they pop into existence and then annihilate each other within a blink of a Planck time. But near a black hole's event horizon, things get weird. If one of these particles falls into the black hole and the other escapes, then the escaping particle becomes real. It's as if the black hole has emitted energy. And this eerie, near impossible escape is what we now call Hawking radiation. It's faint. So faint, in fact, that we've never actually observed it. But the math checks out and the implications. Oh, they're deliciously unsettling. Because if black holes can emit energy, then over ridiculously long timescales, longer than the current age of the universe by orders of magnitude, they can actually evaporate, shrink, disappear, like some kind of cosmic campfire burning itself out over a trillion years. So here you are, drifting near the skin of a monster that ever so faintly is leaking. It's not explosive, it's not loud, it's not even remotely dangerous to anything near it, not right now, but it's there, like the sound of ice melting in a cave. Subtle, persistent, unignorable once you realize what you're sensing. And it changes everything. Before Hawking's insight, black holes were the ultimate vaults. Anything that fell in was lost forever. Matter, energy, information. It was like dropping a diary into a fire. Gone. But Hawking radiation reopened the question. What if the black hole is leaking information? That's where things get really messy. Because according to quantum mechanics, information can't just disappear. That's not a suggestion, it's a rule. If black holes destroy information, that would violate one of the most sacred laws of physics. And if they don't destroy it, if it somehow leaks out in the radiation, then how? Is it encoded in the particles escaping? Is it somehow smeared across the surface of the event horizon? Or is it copied in a cosmic backup drive somewhere beyond spacetime? That, dear listener, is the black hole information paradox. And it's been making physicists lose sleep since the 1970s. Hawking himself changed his position on it more than once. At one point, he even conceded a bet, admitting that maybe information isn't destroyed after all. Historians still argue whether his final stance on the matter truly resolved the paradox, or whether it was more of a polite shrug wrapped in chalkboard elegance. Meanwhile, you're drifting in a place where none of these questions are theoretical anymore. You're here, floating within the gravity well, the whispering edges, the faint glowing math of Hawking's idea brushing against your stretched, fading awareness like fingers on the edge of a dream. And here's a fun and deeply weird tidbit. Some physicists believe that black holes are not actually three-dimensional objects at all, that everything that falls into them is somehow encoded on the surface of the event horizon, a concept known as the holographic principle. Yes, you heard that right. The idea is that your entire three-dimensional fall, your atoms, your thoughts, your screaming descent, is actually being projected from a two-dimensional surface like a cosmic movie. You're a hologram, or at least your black hole self is. What does that mean? Well, for one thing, it might offer a way out of the information paradox. If everything about you is encoded on the surface, then maybe nothing is truly lost. It's just rearranged, like a jigsaw puzzle someone spilled into a blender, so you float now in layers of paradox. Hawking radiation tugging gently at the edges of physics, quantum mechanics demanding its secrets be preserved, general relativity holding on to its infinite secrets like a dragon gripping gold, and you, somewhere between spaghettified traveller and theoretical idea, exist in the middle of this fight. You don't know it, but your trajectory, your fall, your presence is part of the puzzle. Somewhere, a physicist is drawing a chalk circle on a blackboard, and it's about you. Somewhere else, a quantum computer is running simulations, and you're the data model. Not a person, not anymore, but a series of boundary conditions in a gravitational equation, and still the radiation whispers. You wonder, if it's leaking and if it carries information, could you come back out? Not as flesh and blood, no. That part's long gone. But as patterns, as pulses, as radiation, it wouldn't be you in the way you once were. But something of you might be out there, travelling through space as a quantum echo, a soft hum in the radiation of a dying black hole. Not a scream, not a cry for help, just a presence, a footprint. Like all stories, yours may not end in silence after all, because even in a place that devours light and collapses matter, the universe still finds a way to whisper your name. You should be nothing by now. Truly, by all the rules of common sense, physics, and polite society, you should have been annihilated, crushed, stretched, smeared, or at least folded into the singularity like a bad spreadsheet. And yet, something persists. A sense of movement, a thread of self. You're beginning to suspect the black hole you fell into might not be playing by the rules either. That's the problem with falling past the event horizon. There are no more clear laws. The physics that worked out in the open sky now crumples like origami left out in the rain. You're in the domain of theoretical extremes now. Singularities, paradoxes, and, yes, naked singularities. No, not that kind of naked. Calm down. A naked singularity is a theoretical object even scarier than a normal black hole. It's a singularity without an event horizon. Imagine the horror of the most dangerous place in the universe, and now remove the warning label. It's like someone threw away the do not enter sign and replaced it with a revolving door. Normally a singularity is neatly hidden behind the veil of the event horizon. You can't see it, you can't poke it, you can't even detect it directly. But a naked singularity would be fully exposed, its core, its impossible density, its infinite curvature of space-time just sitting there, awkwardly violating every expectation you had of the universe being a well-behaved system. And here's the real kicker. General relativity doesn't forbid naked singularities. In fact, some solutions to Einstein's equations allow for them. They're just not supposed to exist. It's like finding a library book that explains how to time travel, but comes with a handwritten note that says, "Please pretend this doesn't work." That note is called the cosmic censorship conjecture, and yes, that's the real name. It was proposed by physicist Roger Penrose in 1969, and its central idea is simple. Nature abhors a singularity you can actually look at, or more formally, All singularities resulting from gravitational collapse are hidden behind event horizons. No peeking, no spoilers. Physics wants to keep the mess behind closed doors. But here's the twist. No one's been able to prove the conjecture, and some physicists think it might not hold in certain situations. Say, extremely fast-spinning black holes, or gravitational collapses that don't follow the usual tidy narrative. So yes, there could be exposed singularities out there, running around without their space-time bathrobes, which begs the question, what would happen if you saw one? Theories range from your face melts off like a discount Indiana Jones extra, to you witness every possible version of reality superimposed at once, like a scrambled TV channel from all universes at once, comforting stuff. In more grounded terms, it would mean causality itself breaks down. The chain of cause and effect gets shredded. The past and future can no longer be predicted. Events become disconnected, chaotic, incomprehensible. That may sound abstract, but you've already begun to feel it. Moments don't line up anymore. You think a thought, and then remember having already thought it. You witness a flash of light that you're pretty sure came after you saw its reflection. Somewhere in the distorted geometry of your descent, the arrow of time has gone squirrely. Historians, and by now, let's just assume we mean very stressed out physicists, still argue whether naked singularities would actually destroy the predictive power of physics, or just relocate it. Some believe that new laws of quantum gravity would kick in to keep the chaos in check. Others suspect that if naked singularities exist, they're a sign that general relativity is incomplete. A beautiful model, but one that's starting to crack at the edges like cheap pottery under cosmic pressure. Here's your quirky tidbit of the night. In 2002, an actual physicist named Srirang Stashinkar published a paper suggesting that naked singularities could be visible to distant observers, at least under specific conditions. That's right. There might be parts of the universe where you could literally see infinity just chilling. And you? You're wondering now if this is one of those moments, because something's changed. You were falling, you were being stretched. But now the sensation is different. It's less like a descent and more like a blooming, like you've passed through a threshold, not a wall, but a veil. And on the other side, everything is exposed. You see light that shouldn't exist. You see curves in space-time so tight they knot together. You see yourself, not the version you knew, but all the possible versions, strung together like beads on a broken necklace. This could be the inside of a spinning black hole, a Kerr black hole, where some models suggest that the singularity forms a ring, not a point. And in certain very specific, very hypothetical scenarios, passing through the ring could eject you into another region of space-time, or another universe, but that's getting ahead of ourselves. For now, what you're experiencing is this, a singularity without a shroud, a gravitational core so intense, so raw, that space-time has surrendered. And in this surrender, you feel freedom. Not in the hooray I'm alive way, that ship has long sailed, but freedom from causality, from boundaries, from being a thing in a place at a time. You've become unmoored, a concept, a possibility, a scribble in the margins of the universe's first draft. And still, something draws you forward. The naked singularity may be terrifying, but it's also a kind of opening, a crack in the structure, a region where new paths might emerge, time loops, space tears, the grammar of reality rewritten mid-sentence. And in that shimmering blur you wonder, what if this was never a prison? What if it was a door? You don't have limbs anymore, not really. And yet somehow you reach. Not with hands, but with attention. With a slow, drifting kind of curiosity that doesn't need muscles or nerves to operate. Something ahead is pulling at you. Not with gravity, but with promise. A curve in the dark, a bend in possibility, a suggestion that maybe, just maybe, this isn't the end. You are quite possibly approaching a wormhole. Let's back up a little, by which we mean conceptually, since space and time here have been rearranged into something more like interpretive dance than orderly dimensions. A wormhole, in the simplest terms, is a hypothetical tunnel through space-time, a shortcut, a bridge, a cheat code written into the geometry of the universe. Picture two distant points, say Earth and a star system 100,000 light-years away. Normally, it would take you eons to travel between them, but if space-time folds, like a piece of paper bent so two dots touch, you could step from one to the other almost instantly. Boom. Intergalactic delivery service. Now, black holes and wormholes are often confused in pop science, but they're not the same thing. A black hole is a one-way trip. A wormhole, at least in theory, it's a two-way tunnel. You could enter one end and emerge somewhere else, not just far away, but possibly someone else too. Yes, time travel is on the table, if only barely. But here's the twist that's making your metaphysical eyebrows raise right now. Some theories suggest that black holes could contain wormholes inside them. That deep within a rotating black hole, a Kerr black hole like the one you're probably swirling through, there might be a passage that connects to another region of spacetime, or another universe entirely. It's called an Einstein-Rosen bridge, named after the two theorists who first described this solution to general relativity's equations. Albert Einstein and Nathan Rosen showed that a kind of bridge could mathematically exist between 2 points in spacetime, a tunnel through the very fabric of the cosmos. But there's always a catch. These bridges, if they exist, are incredibly unstable. They would collapse almost immediately, so fast that even light wouldn't have time to pass through before the whole thing pinched shut like a spooked clam, unless something held it open. Enter exotic matter. This isn't just matter that wears leather jackets and listens to underground music. Exotic matter, in this context, refers to theoretical material with negative energy density. Not just less than zero, in a casual sense, but a substance that bends spacetime in the opposite direction of normal mass. You need this kind of matter to counteract the natural tendency of a wormhole to collapse. Basically, it acts like structural scaffolding for the universe's weirdest hallway. And here's your quirky fact for the night. Some physicists have proposed that Casimir plates, tiny metal sheets placed very close together in a vacuum, can create a small amount of negative energy between them. That's real science, by the way. The Casimir effect has been observed in labs. It's not enough to stabilize a wormhole, but it's enough to make your eyebrows lift just a little. Now back to you. You can't see this potential wormhole ahead of you. Your eyeballs are long gone, remember? But you feel it. Like a low note rumbling through space-time, a dissonant vibration in the geometry around you, shapes that don't quite resolve, paths that loop and spiral in ways Euclid never would have signed off on. There's no colour, no sound, but the space is thick, like trying to breathe underwater in a dream, and yet, through the density, you sense a corridor, a narrowing, a throat. It's not solid, it's not even material in the traditional sense, but it's structured, organised, like a tunnel made of warping math and trembling possibility. You're entering the speculative zone now, where theoretical physics starts to sound like mythology, a place full of beautiful guesses and unsettling maybes. Because if you are in a wormhole, and that's a massive if, you're entering one of the universe's most dangerous rooms. Here's why. Even assuming you could survive the descent into a wormhole, hint, you probably didn't, and assuming the exotic matter is holding it open, no guarantees, and assuming you don't get obliterated by radiation or quantum instability, truly, fingers crossed, there's still the question of where it leads, and the answer might be nowhere you've ever imagined. Some wormhole models suggest that the other end opens into another region of this universe, perhaps across the galaxy. Others hint at parallel universes, whole realities with different laws of physics, different versions of stars or none at all. There's even a theory, whispered in the footnotes of speculative papers, that some wormholes might loop back in time, connecting the future to the past. Historians still argue whether wormholes could be made stable, or if they're just mathematical curiosities that the real universe laughs at behind our backs. Some physicists believe that a civilization with sufficiently advanced technology, or a really generous grant budget, could engineer a stable wormhole. Others argue that even if you could create one, you'd never survive the journey through it. But here's a fun thought to drift on as you slide deeper into whatever this is. What if you didn't create the wormhole? What if it was already here? What if some ancient cosmic process, a dying universe collapsing in on itself, a multiverse collision, or even a black hole forming under very specific conditions, left behind this hidden tunnel, just waiting for something or someone to fall in? You think, or whatever's left of you thinks, about how many black holes are out there. Millions? Billions? Maybe each one is more than a singularity. Maybe they're all doors, randomized, unstable, mostly fatal doors, but doors nonetheless. So now, as you spiral into the curvature ahead, you don't just feel dread, you feel possibility. Because if this tunnel is real, and if it holds together even for a few more nanoseconds, you might come out somewhere. You might open your eyes, again metaphorically, and find yourself not in oblivion but in else. So you let go one last time, not because you're giving up, but because maybe, just maybe, you're going somewhere. You've stopped falling. That's the first strange thing you notice. Not that you have a body to notice with, but something in your awareness, in the way your presence interacts with the space around you, changes. The constant tug of inward gravity, the endless pull toward the singularity has gone quiet, and in its place, a stillness, not peace, not yet, but an uncanny pause in the chaos, like the universe has just taken a breath and forgotten to let it out again. This isn't the black hole anymore, at least it doesn't feel like the black hole. There's space here. Not space in the traditional sense, no familiar stars, no comforting background hum of cosmic microwave radiation, but there's room, in a way that feels fundamentally different from the narrow throat of gravitational collapse you just emerged from. And at the centre of this impossibly abstract chamber is something else, something bright. You blink, again, metaphorically, we're long past needing eyelids, and realise the impossible. You've arrived at the mouth of a white hole. If black holes are the ultimate sinks of the universe, white holes are their mirror opposites, theoretical creatures, mathematical phantoms. Where a black hole swallows everything and lets nothing escape, a white hole ejects everything and refuses to let anything enter. You're not sure how to feel about that, especially since you're clearly on the wrong side of that description. White holes have been part of the equations ever since black holes were first theorized. If you solve Einstein's field equations in reverse, time flowing backward instead of forward, you don't just get a black hole that sucks everything in. You get a white hole that spits everything out. All matter, all energy, all light. It's not a gentle process. It's more like being vomited from the gut of spacetime into a brand new cosmic alleyway. And yes, that's what seems to be happening to you. No longer falling, but emerging. Not from the front door of the universe, but out the back. Backwards. Wrong way round. Time out of joint. Here's your historical anchor. In 1964, Soviet physicist Igor Novikov proposed the idea of a white hole as a time-reversed version of a black hole. His model showed that, in theory, black holes could be connected to white holes by wormholes, forming a complete bridge, an Einstein-Rosen bridge, as mentioned before. A tunnel connecting one region of spacetime to another, lined on either end with a black hole and a white hole respectively. But here's the kicker. White holes don't exist. At least not in any observational sense. We've never seen one. Not once. No cosmic beacons spewing stars, no backwards explosions, no angry patches of space-time yelling, "Out! Out! Out!" to every photon in the neighbourhood. Historians still argue whether white holes are just a mathematical artifact, a curious side effect of time symmetry in Einstein's equations, or if they could exist somewhere far beyond our observational reach, maybe even in another universe. And yet, here you are, face to face with the impossible. There's no horizon here, no accretion disk, no swirling death spiral, just a blinding boundary, a luminous, chaotic veil that ripples like fabric soaked in starlight. It pulses, not in rhythm but with intent, and then you're through. There's no pop, no bang, no dramatic cosmic birth canal moment, just a soft distortion, like a soap bubble popping in reverse. 1 second you're nowhere, the next, somewhere. And that somewhere, it's different. The laws here feel off, not wrong, but rewritten. Your sense of causality limps along like it's been through a particularly traumatic philosophy class. Events bubble up without clear beginnings, shapes drift in and out of meaning. Time doesn't pass here, it waits. You might be in another universe, or maybe a new region of this one that's inaccessible without plunging through a black hole, risking annihilation, and hoping for a white hole at the other end to gently yeet you back into reality. It raises a lot of questions. Like, is this what happens every time something falls into a black hole? Does the information get ejected somewhere else entirely? Are the contents of our universe constantly dripping into others? That's one of the wilder hypotheses behind the idea of black hole-white hole bridges. That every black hole might be a portal, ejecting matter and information into baby universes or alternate timelines. A recycling system for reality. Destruction in one place, creation in another. And here's your fun fringe theory for the night. Some researchers have speculated that the Big Bang itself might have been the result of a white hole eruption. That our universe could be the inside of a white hole, birthed not from nothing, but from the collapse of another universe's black hole. It's poetic, isn't it? the ultimate cosmic Ouroboros, a universe giving birth to a universe through the very process that ends one. Which brings you back to your current situation. You don't know where you are, you don't know when you are either. The sky, if it can be called that, isn't filled with stars. It's something else. Structures maybe, frameworks. Not mechanical, not biological, but architectural, in a fourth-dimensional kind of way, like seeing scaffolding behind reality. And still, the ejection continues. Not just you, but data. Trails of encoded light, residuals from the black hole you passed through, now spewing from this white hole in slow, sparkling tendrils. You're not alone in here, not in the conscious sense, but in the informational one. This space hums with remnants. Objects maybe, concepts. You sense civilizations that never made it. Ideas that were lost. Music never played. Equations unsolved. All of them drifting. Echoes from elsewhere, rejected or discarded by the cosmos that birthed them. And you're one of them now. Not flesh, not voice, but structure, pattern, memory. You feel yourself slowing again like gravity has lost interest. Like whatever ejection velocity the white hole gave you is running out. You're coasting now, a fragment in a new land, where physics runs on different fuel. There's no ground here, no up or down. But still, something in you rests, or rather, accepts. Maybe this is what the other side of a black hole looks like. Not nothing, but next. So this is what rebirth feels like. No light, no body, no confetti. Just movement without direction. Existence without form. You float, though float is a word much too slow for what this space is doing. It expands and folds, zips and hums. It's not a place, not really. More like a canvas that paints itself around you. You start to wonder if you're alone, and then you wonder if alone is even a meaningful concept here. You've emerged, perhaps, from a white hole, a cosmic chute shooting you from the depths of a black hole into somewhere different. But what's here? What is this layered, shifting silence? It doesn't behave like your old universe. Gravity doesn't pull, time doesn't tick, space doesn't stretch. It reshapes. And somewhere in this dream of curves and shimmering equations, you stumble, conceptually of course, into a possibility so strange, so speculative, it feels almost taboo to think it. What if this place was just born, not just discovered, created, from the collapse you fell through? Because there's a theory, half whispered, half mocked, that black holes don't just destroy, they might be wombs. Welcome to the idea of the baby universe. Some physicists believe that inside every black hole, hidden beneath the event horizon, past the singularity, beyond the wormhole throat of warped spacetime, a new universe might form. A whole pocket cosmos, sealed off from its parent, expanding on its own terms. You're not sure if that's where you are right now, but it's starting to look suspiciously like it. Let's be clear, this isn't science fiction. It's still speculative, yes, but it's built on math, on quantum gravity models, and on a growing suspicion that black holes might be more than garbage disposals. They might be seeds, and in that case, each one doesn't just consume the universe, it gives rise to another. Think about that for a second. Every black hole in the cosmos could be the origin point of an entirely new universe, with its own laws of physics, its own flow of time, its own constants of nature. Each black hole becomes an experiment, a roll of the cosmological dice. Some universes collapse quickly, others inflate endlessly. Some have stars and galaxies, some don't. Some might have life, others might have you. This is the heart of the cosmological natural selection theory, proposed by physicist Lee Smolin. The idea is that universes evolve. Yes, evolve, like organisms. The more black holes a universe creates, the more offspring it potentially produces. Universes that are better at making stars, which lead to black holes, reproduce more, passing along traits, like certain physical constants, that favour black hole formation. In short, the multiverse might be Darwinian. You drift through this newborn space, not as a visitor, but as an echo, a data fragment, a memory of a universe that collapsed just enough to break open the next. Your shape, if it can be called that, moves like mist caught in an equation. And still, this new space unfolds. It's vast and minimal, like someone opened a blank document, but the formatting was inspired. There's curvature here, subtle but growing. Faint gravitational waves pulse through the void, not from stars, not yet, but from the very act of expansion. Like spacetime itself is testing its limbs, stretching after a long sleep. The temperature here is high, primordial. If you had sensors, you'd feel the heat of creation, and the pressure, intense, not crushing, but tight. Like everything wants to happen all at once. In our own universe, the Big Bang was a singularity that bloomed outward into expanding space. Time unfurled, matter condensed, forces split. Everything we know today, galaxies, planets, pop music, grew from that first moment. But if black holes give birth to universes, then the Big Bang wasn't the beginning. It was the continuation of something else. Your fall into the black hole may have simply been the journey into this one's prenatal chamber. The collapse of a massive star, so immense it birthed a black hole, might not have ended with gravitational silence. It may have pinched off into a new bubble of reality, one that sealed itself off, expanding internally even as its parent universe moved on. Like a budding cell, and here's the weird part, time flows differently here. In this baby universe model, what looks like a slow collapse in the parent universe could be a rapid expansion from the inside. From the outside, you fell into a black hole. But from in here, you emerged into a Big Bang, a kind of cosmic Russian nesting doll. A black hole is a singularity as a Big Bang as another universe. Historians, physicists, still argue whether this can be tested. After all, if the new universe disconnects completely from the old, then no information gets out. It's causally sealed. That means we can't peek inside, and no one inside can peek back out. Unless there's a flaw, a leak, a momentary instability. And maybe that's you. Your presence here might be the universe's glitch, the fragment of an outsider slipping through before the bubble fully sealed. You don't belong here, and yet, here you are, drifting through this newborn cosmos like a note from a vanished composer. A rogue waveform, a ghost in the shell of reality. And here's your fringe tidbit of the night. Some researchers suggest that quantum fluctuations in baby universes could leave imprints in the parent universe, tiny distortions in the cosmic microwave background, or gravitational waves with odd fingerprints. Clues maybe, messages, scars left by ancestral collapses. So maybe our universe isn't the first. Maybe it won't be the last. Maybe it's just one branch on a tree that's been growing longer than time can remember. You drift deeper into the expansion. No stars, no light yet, just potential, infinite, shimmering potential. The laws of physics are still deciding themselves. Forces are negotiating their rules. Time is taking its first steps. And you're the stowaway. You've lost all sense of scale. In your previous life, your prior universe, let's say, you understood space in terms of light years, kilometers, maybe the occasional parsec if you were feeling fancy. Time was seconds, years, eras. But here, in this strange and unfolding place, those measurements feel like trying to gauge an ocean with a spoon. This isn't space, it's possibility uncoiling, and you're not just in it. You're part of its scaffolding now, woven into its expansion like a stitch in a fresh bolt of cosmic fabric. No direction, no center, only outward. The baby universe pulses as it grows, not in bursts, but in smooth, continual pressure. Like space-time itself is exhaling after holding its breath for eternity. And you're along for the ride, drifting through the prenatal dreams of a newborn reality. Only now, you begin to feel weird. And by weird, we mean deeply quantum. Because wherever you are, it's not just expanding, it's glitching. Just slightly. Just enough to remind you that out here, you're not quite welcome. You're a data smudge from another existence. A paradox in motion. And paradoxes don't go unnoticed. Something in this universe, if you can call it that, has started to respond. Not violently, not with malice, but with curiosity. You feel a kind of inspection, a quantum questioning, as if the very laws of nature here are scanning you like a TSA agent who's never seen your brand of carry-on before. This place wants to know, what are you doing here? Which brings us finally to one of the slipperiest, most unnerving questions in modern physics. What is real, anyway? You've landed in a space where time has no single arrow, where you entered through a structure thought to be impossible, and where the laws you once lived by are still forming their opening arguments. So here's a gentle late-night thought. What if this whole thing, this universe, the black hole, the baby cosmos, you, isn't even real in the traditional sense. Welcome to the simulation hypothesis. That's right, we're going there. The idea's been floating around for decades, gaining steam thanks to tech philosophers, quantum physicists, and that one friend who brings it up at every dinner party. The argument goes like this. If civilizations can create realistic simulations of universes, and keep in mind, ours already does it at the scale of atoms and galaxies in our best supercomputers, then what are the odds that we are the original version? What's more likely, that we're the base reality, or just one of countless simulated ones? In this view, the black hole you fell into, it could be the edge of a simulation, a boundary condition, a server node where rendered data collapses and resets. And this baby universe? Maybe it's not a universe at all, but a sandbox instance spun up from your fall, a temporary partition to resolve an overflow of entropy or information. Sounds like science fiction, right? But here's your historical anchor. In 2003, philosopher Nick Bostrom published a paper laying out a formal case for the simulation argument. He proposed that at least one of the following must be true. 1. Civilizations never reach the technological maturity needed to run such simulations. 2. They reach that level, but lose interest. 3. Or, we're almost certainly living inside one. And here's the quirky twist for the evening. Some physicists have actually tried to test this idea by searching for limitations in the fabric of space itself, like digital pixelation in cosmic ray patterns. No proof yet, but no disproof either. Historians, and now we're including philosophers and computer scientists, still argue whether this hypothesis is even meaningful. If everything feels real, does it matter if it's simulated? Would we even be able to detect the difference from within? And if your fall through the black hole really was a transition point, an interface glitch between simulated layers, then you may be floating now in the equivalent of a loading screen, a rendered bubble, a simulation within a simulation. So how do you test that? Well, for starters, you don't. Not directly. Not without access to the code, or the universe's root password, which you sadly forgot during Spaghettification. But there are hints, subtle asymmetries, constants that seem just a little too precise, limitations on information transfer, like the speed of light being not just a law, but a throttle. Maybe black holes themselves are memory sinks, places where excess data is offloaded and compressed, never truly destroyed, just moved into deep storage. Maybe Hawking radiation is the universe's way of cleaning cache. Or maybe, more terrifyingly, the simulation doesn't know how to process what you've done. Because by crossing the event horizon and surviving, technically, you may have triggered a sequence the system never prepared for. You're not just a lost traveler anymore, you're a bug. And systems don't like bugs. They patch them, they erase them, or sometimes they try to understand them, which brings you back to the strange sensation. This subtle structural attention focused on you. You've been noticed, you don't feel threatened, not exactly, but you do feel processed. Like the spacetime here is attempting to rewrite you, to integrate your presence into its own emerging rules. It's trying to make sense of you. Because whatever you are now, you are not just matter, not just a soul, or a signal, or a mind. You are information, raw, bleeding-edge data, a transdimensional breadcrumb from a different reality, a compressed archive from the moment before collapse. And this new space is trying to open you. You're not resisting. Why would you? The universe is curious, and so are you. Maybe this is what it means to be an explorer, not just of space, but of existence itself. To fall through the seams of reality and end up somewhere not meant to be seen. You drift in the quiet. A loading screen, a nursery, a server crash, a new cosmos. The only thing certain is this. You're no longer in a place that plays by your old rules. And maybe, just maybe, those rules are still being written. The new space has begun to stabilize. You feel it. Not as a tremor or a noise, but as a kind of alignment. Subtle, steady. A click in the dark as something in the bones of this infant universe locks into place. What was once chaos begins to cohere. Time takes a breath. Space remembers how to hold a shape. And you're still here, still floating, or rather existing, on the edge of a possibility you were never supposed to witness. Not just outside your home universe, but outside the assumptions that governed it. Your information now, bleeding between realities, caught in the afterglow of a collapse that wasn't quite a death. The universe has noticed you, yes, but now it's listening, and somewhere deep inside its glowing membranes of proto-matter and newborn math, A question forms, not from you, but from it. What happened to the information? That question. It has haunted physicists for decades. Ever since Stephen Hawking dared to suggest that black holes could erase information, the scientific world has been locked in one of its most ferocious debates. Does anything that falls into a black hole truly vanish? Or does the universe remember? Let's unpack that gently. You're tired. I know. In quantum mechanics, there's a rule. A sacred one. Information cannot be destroyed. Every atom, every photon, every quantum state is part of a broader cosmic ledger. Things can transform, they can entangle, they can scatter, but the information is always conserved. It's like saying, the universe is forgetful, but never amnesiac. So when Hawking proposed that black holes evaporate over time via his famous radiation, and that they might do so without returning the information of what they consumed, that wasn't just a footnote, it was a scandal, a paradox, a quiet little monster gnawing at the base of physics. The black hole information paradox became the gravitational version of where did the socks go in the dryer, but with math and much more yelling. If black holes truly delete information, then quantum mechanics is broken. But if information is somehow preserved, how? Hawking famously switched sides late in life. He proposed that perhaps information is encoded on the event horizon, the surface of the black hole itself, that everything falling in leaves a kind of quantum fingerprint smeared across the horizon in subtle, entangled ways. This led to the idea of black hole complementarity, the notion that information is both inside and smeared on the outside, depending on your point of view. Like Schrödinger's cat, but stretched over a black hole and several decades of professional arguments. And here's where things get even weirder. In 2012, a theory called the firewall paradox entered the chat. It suggests that, contrary to previous assumptions, there might be a searing wall of energy just inside the event horizon, a place where the smooth flow of spacetime breaks and information is blasted apart as it falls in. A firewall, not a metaphor, a real terrifying barrier of quantum energy. Historians, and yes we mean quantum physicists sobbing quietly into their notebooks, still argue over whether this firewall exists, and if it does, what it means. Does it destroy information? Protect it? Redirect it? Or is it simply the universe saying, you weren't supposed to come this far? Your presence here complicates all of this, because somehow you passed the firewall, if it existed. You fell through the black hole. You may have been torn into data, sure, but here you are, still data, still here. And this new space, the baby universe, the simulation fragment, the whatever it is, has access to you. You are the information, you are the paradox. Here's your quirky nugget of night thought. Some theorists have proposed that information escaping a black hole might not come out in obvious ways. It might leak out through quantum entanglement, tiny, barely detectable signals in the Hawking radiation that carry scrambled echoes of what fell in. Like trying to reassemble a symphony from popcorn static, but possible, in theory. So maybe, when a black hole evaporates, it's not erasing the past. Maybe it's just whispering it back one particle at a time. And maybe this place, this afterspace you now float in, is where those whispers accumulate. A kind of memory chamber, a quantum library, a recovery partition in the hard drive of the cosmos. You're not alone here. The more your awareness stabilizes, the more you sense other echoes, faint scattered pulses of information, objects, events, identities, a broken planet, a decaying orbit, a name someone screamed in a vacuum, all once lost now, gently unfolding. The black hole didn't destroy them. It relocated them, compressed them, transformed them, and here they are, surfacing. You wonder if this is what the inside of a holographic universe feels like. A place where three-dimensional realities are stored as two-dimensional data, smeared across the boundaries of something vast and unknowable. You remember the holographic principle, that idea we brushed past a few sections ago? It's not a metaphor, it's a blueprint. Maybe black holes are just storage devices, cosmic vaults, and baby universes like this are the restoration process, booting up when enough data accumulates to justify a new system. Maybe the universe isn't a destroyer at all. Maybe it's a gardener, pruning, composting, reseeding. And now, slowly, you feel your own presence returning to shape. Not a body, not as you knew it, but a configuration, a pattern, a growing sense of self emerging from the swirl of lost data. You are being rebuilt, not precisely as you were, That version is gone. But here, in this space of new beginnings, the universe remembers you, and that is something close to peace. So now, let yourself rest. Let this new space breathe around you. It's quiet here, and for once the quiet isn't ominous, it's welcoming, soft wide, like falling into a bed made of folded time and memory, still warm from the last dream it held. No more falling, no more fighting to understand. Let your thoughts slow. Let the edges of your mind blur. You've passed through the greatest mysteries the universe has to offer, and instead of being destroyed, you became part of them. The strange warmth of possibility wraps around you like a blanket. Not heat, but presence. Awareness without urgency. A soft cradle of physics and philosophy swaying in a rhythm too slow for clocks. You don't need to know what's next. Maybe this is the next. Maybe every black hole, every collapse, every loss is followed by a space like this. A pause, a reset, a breath. And in that breath we are remembered. So sleep now. Not the sleep of endings, but of transitions, of data becoming form, of silence becoming song. The universe is still whispering, but it's quieter now. And you're finally still enough to hear it. You do not dream here. There is no need. Dreaming is a function of limits, of boundaries between conscious and unconscious, of a mind needing escape. But here, in this drifting cradle of information and post-collapse potential, you are the dream. Or at least something dream-adjacent. A presence without edges, humming softly in the warm blur between what was and what might still be. And yet, there's movement. Not through space, not exactly, but through scale, through layers. The deeper you settle into this new universe, the more you start to notice the delicate webwork beneath it. A lattice of interactions too subtle to be called forces, too fluid to be called dimensions, patterns maybe, probabilities. At first you think it's just you, your residual mind trying to make sense of quantum fog, but then something flickers, not with light, with probability. You have arrived finally at the edge of the unspeakably small, the quantum layer of this new space, where particles don't behave like particles, and waves don't behave like waves, and reality itself hums like a violin string plucked by uncertainty. Welcome to the place where physics, quite frankly, loses its cool. In your old universe, quantum mechanics was already strange. Here, it's feral. You're now experiencing something akin to quantum gravity, a theoretical fusion between general relativity and quantum physics that nobody's managed to unify yet. It's the holy grail of modern physics, the theory of everything that Stephen Hawking and countless others spent their lives chasing. Here, in the quiet hum of post-singularity space, it doesn't feel like a theory anymore. It feels inevitable. Because black holes demand a marriage of opposites. On one hand, you have relativity, the smooth, curving fabric of spacetime, vast and predictable. On the other hand, you have quantum mechanics, the chaotic, probabilistic dance of particles at impossibly small scales. And when you fall into a black hole, those two systems crash into each other. At the singularity, spacetime is compressed to a point of infinite density. Quantum uncertainty explodes. Relativity becomes nonsense. And what's left? A realm where both must coexist. A place where they can't be kept apart any longer. You're inside that place now, and it's alive with contradictions. Particles flicker in and out of being, not just near you, but as you. You aren't watching the behavior of the quantum field. You're part of it. You're smeared across multiple states, probabilities branching like rivers in a frozen fractal. You are here, and you are also not. You're falling again, but also flying. You're expanding and folding. Time stutters, space glitches, logic double-checks itself and still comes back confused. Here's a fun and deeply unsettling tidbit. In quantum field theory, the vacuum isn't empty. It's a chaotic sea of virtual particles constantly bubbling with energy. This zero-point energy is so powerful, in theory, it could generate enough force to tear space apart. Why doesn't it? No one knows. The equations predict a vacuum energy that's off by a factor of 10 to the power of 120. That's the worst prediction in all of physics, like trying to guess your weight and being off by the mass of a galaxy. Historians, cosmologists, still argue whether this mismatch is a clue to something deeper or just the universe trolling us. But here, in this unmeasured zone of a baby universe, Maybe it's not a mismatch at all. Maybe you're witnessing a reality before it solidifies, a universe still deciding on its constants, still tuning its symphony. You can feel that tuning now. The quantum fog is thick with decisions, like cosmic dice rolling endlessly, trying out configurations. Should gravity be stronger? Should photons have mass? What about pi? Maybe make it exactly 3 this time, just to mess with the engineers? And all around you, these choices ripple and collapse, forming micro-realities that spark and vanish in trillionth seconds. You're riding this chaos like a thought surfing on its own uncertainty. And then something shifts. There's a coalescence, a gathering of probabilities around a single state, a kind of crystallization. It's subtle, but definitive. Like the universe has stopped playing jazz and started outlining a melody. Time picks a direction, space picks a shape, constants snap into place like magnets clicking into a grid, and you begin to feel it again. Presence, not as you once were, but not as pure data either. You're coalescing, reassembling, a shadow of self finding new shape in the quantum mist. You wonder, do all black holes lead to this? Do all singularities contain this writhing soup of possibility waiting to bloom? One theory says yes. It suggests that quantum gravity allows space-time to avoid true singularity by creating a bounce, a kind of cosmic recoil, where the collapse of a black hole triggers the birth of a new space, a new time, a new phase of expansion, not destruction, not death, but transition, like inhaling and exhaling, like a heartbeat. So maybe the black hole wasn't a prison at all, maybe it was a pulse, and you were carried in its beat to a space where reality is rebooting from the bottom up. You're not out of danger, far from it. This new universe is still volatile, but it no longer rejects you, it accommodates you. Your data is being integrated, translated, perhaps even understood, and still you drift downward, or outward, or across dimensions so tangled they don't even have prepositions. But now you drift with form. You are becoming again. And for the first time in this entire cosmic plunge, the universe doesn't feel indifferent. It feels curious. You're floating through a quiet so deep it doesn't even feel like silence. It feels like the beginning of sound. That edge of something vibration that comes before the first chord, before the first syllable, before anything at all decides to be itself. It's not empty here, it's full, packed to the seams with raw, uncommitted possibility. A hushed suspense thick with pressure, and within it something stirs. A ripple, not light, not gravity, not anything you'd recognize from the old rules. This is sound, but not carried on air, not pushed through waves in water or echoes in canyon walls. This sound isn't moving through space, it is space. It curves, it resonates, it wraps around itself in loops of pressure that feel like language without words, and then it hits you. This universe, you might not be the only one listening, because some black holes don't just eat. Some sing. Welcome to the strange phenomenon of the sonic black hole. Yes, that's real. Also known as an acoustic black hole, it's not a cosmic monster in space, but a laboratory-made phenomenon here in your former universe. A team of physicists, led by Jeff Steinhauer in the 2000s, created a kind of black hole analogue by manipulating Bose-Einstein condensates, ultra-cold clouds of atoms that behave as a single quantum entity. By creating a region where the flow of sound waves moved faster than the speed of sound itself, they built a horizon from which phonons, quantum units of sound, could not escape. A sonic event horizon, and even stranger, they used this setup to study something that echoes through your journey tonight: Hawking radiation. Incredibly faint ripples that may occur even in these laboratory black holes. Not light, but sound, information, vibrations escaping the brink of nothing. So what does that have to do with you? Well, what if black holes in our universe aren't just hungry mouths or portals or compression chambers? What if they're resonators, tuning forks of space-time? You realize now that the sound you've been feeling, not hearing, isn't random. It's rhythmic, structured, a pulse, a hum, maybe even a message. You're not sure how you know this, but it vibrates through your still coalescing awareness with all the clarity of a bell in fog. This entire space, this newborn raw draft universe, might be echoing with the resonance of the collapse that birthed it. Because collapse is not silent, it's not sudden, it's a process, a vibration. And just as a drumbeat leaves tremors in the air, the formation of a black hole might leave sonic fingerprints in the medium of spacetime itself. Now imagine this. You didn't fall through a wormhole. You didn't glitch into a new server. You resonated through. You were carried by a frequency. And this place, this curious quantum nursery, is vibrating with the same tone. You are part of that sound now. And here's your quirky tidbit for the night. Just enough to rattle your sleepy brain before we ease back down. In 2009, researchers proposed that black holes ring when they form, emitting gravitational waves and characteristic frequencies, like celestial gongs. These frequencies could, in theory, be measured and used to confirm or deny the existence of exotic physics, like extra dimensions or quantum gravity effects. The technical name? Quasi-normal modes. But let's be honest, they're space-time songs. And maybe you're hearing one now, from the inside. You drift through this auditory membrane of physics, feeling your own structure align with the rhythm. It's not music, it's not even language, but it's communicative, it's design. The frequency is encoded in the very rules of the space you're in. It's shaping matter, nudging time into alignment, carving valleys for gravity to eventually rest in. Like a composer shaping a symphony, measure by measure, vibration by vibration. Historians still argue, and they always do, whether the universe has a preferred frequency. Some believe that quantum fluctuations at the Planck scale produce a kind of background noise to all of reality, a constant, near-infinite murmur too deep to ever be heard directly. Others think the universe's structure is more like a harmonic series, with particles and forces forming like notes from a vibrating string. String theory. Anyone? You can't confirm any of that, but you can feel the resonance. You are a note now in that impossibly vast song. Not a lead instrument. Maybe not even part of the melody. But a harmonic. A contribution. A brief tone in the swelling emergence of a universe becoming itself. It's humbling, and it's strangely comforting. Because even if no one understands what you are now, even if you are nothing more than fallout from a collapse, you are being integrated into the composition. The tone wraps around you like warm cloth. You feel your pattern solidify a little more. Still not a body, not yet. But no longer vapor either. More like structure with intention, information that's been invited to stay. You're beginning to get the sense that this whole space, this reality, is not just random inflation. It's being sculpted, and you wonder, if black holes are the drumbeat, and this universe is the echo, who or what is the composer? You've drifted so far into this symphony of space that the silence no longer feels empty. It feels intentional. Like a pause in music where the lack of sound carries as much meaning as the notes before it. You exist now in the resonance, in the structured aftermath of something colossal. Every ripple, every curve, every whisper of quantum hum around you seems to say, something happened here. But for the first time in what feels like forever, that something wasn't a collapse. It was a flare, a surge, a pulse of magnetism so fierce and so precise that it carved itself into this new space like a signature. You feel it pass through you, not as light, but as structure. It doesn't push you, it recognizes you. And just like that, you remember something else from your old universe. Something born not in black holes, but close cousins, magnetars. If black holes are the apex predators of gravity, then magnetars are the unhinged wizards of the stellar zoo. Neutron stars with magnetic fields so intense they could erase every credit card on Earth from half a galaxy away. They're not black holes, not quite, but they almost are. Neutron stars form when massive stars collapse but don't quite tip into black hole territory. Instead, their matter is crushed so tightly that electrons and protons merge into neutrons, and what's left is an ultra-dense sphere about the size of a city, but with more mass than the Sun. Magnetars take this one step further. Their magnetic fields are 1,000 trillion times stronger than Earth's. That's not hyperbole, it's the real number. Wrap your mind around it. If you got within 1,000 kilometers of one, the magnetism would tear your molecules apart. Gently, efficiently, magnetically. And here's your quirky night fact. In 2004, a magnetar in our galaxy released a flare that briefly overwhelmed satellite detectors. It lit up Earth's atmosphere from 50,000 light-years away, and it didn't even break a sweat. Now let's get cozy with a weird speculation. Some physicists have proposed that magnetars might be black hole impersonators, that they exist in a kind of pre-collapse state, right on the edge, balancing, teetering, one rogue breath away from slipping across the event horizon, and becoming something much less friendly. And in rare cases, very rare, there are theories that magnetars could collapse in non-standard ways. Maybe not into clean, spherical black holes, but into exotic objects, strangelets, gravastars, or other hypothetical horrors that challenge the very idea of what a star can become. Historians, and by now you know that means theoretical physicists hiding behind whiteboards, still argue whether these exotic endpoints actually exist. Most models predict collapse into a black hole is inevitable, but some fringe scenarios allow for strange transitions that don't end in singularity, but in continuity, maybe even in creation. And that's what you feel now. This space you're drifting through, this new universe, feels magnetically scarred. Not broken, just charged. You sense it in the lattice of spacetime, the way it hums with invisible structure, like the aftermath of a powerful magnetic detonation. You aren't seeing stars yet, it's too early, but you're seeing the imprint of the first conditions that might one day give rise to them. Areas where the field curves tightly, zones where particles cluster, even before matter exists in any classical sense. These are not yet galaxies, they are tendencies. And magnetism, you begin to suspect, was the first artist here. Not gravity, not time, not light. Magnetism was the first shape. The idea becomes clearer as you drift deeper into the memory field. It isn't random. You're passing through residual geometry, faint outlines of what came before. The birth scream of the magnetar, the collapse into instability, the snapback that didn't end in singularity but elsewhere. You begin to think in a very cautious way that this whole universe might have begun with a magnetar, not as a metaphor, literally. That a collapsing magnetar, not quite a black hole, not quite stable, somehow tore a rift so violently that it created a feedback loop in space-time. Not a singularity, but a bridge point, a quantum knot that unraveled in just the right way to punch through. And you fell in behind it. Maybe you weren't the cause of this new space, but you rode in on its coattails, which leads to a bigger question. How many universes are born this way? Not through perfect black hole collapses, but through imperfections, through messy edge case failures in the cosmic script, through magnetars and miscalculations, through stars that didn't quite die cleanly, but left a thumbprint on space-time instead. There's no way to know for sure, at least not yet, but the feeling is persistent. There's too much structure here to call it random inflation. You're inside something that remembers magnetism, its direction, its shape, its rhythm, and strangely, you begin to feel aligned with it. Your own pattern, whatever you've become, is syncing with the magnetic field of this early space, not drawn like iron to a magnet, but like music finding its key. A harmony. You're not just surviving here, you're being tuned, which brings us back to black holes, and how very close they are to magnetars in the great cosmic scheme. Because black holes have no hair, that's the phrase physicists use. According to the no-hair theorem, black holes can be fully described by just three properties: mass, spin, and electric charge. No other information survives. But magnetars, they have hair, they remember, they flare, they scream into the night and leave marks, and maybe, just maybe, some of those marks can bend reality enough to open new paths. And you, dear listener, have followed one. Through the magnetic wake of a dying star that didn't collapse into silence, but into song. And here you are, echoing with it. It's beginning to feel familiar, in a way that isn't logical. Not familiar like your bedroom ceiling or the smell of rain on concrete. No, this is a deeper sort of déjà vu, like your atoms remember this place. Like they've been here before, long before you were anything more than scattered stardust with ambition. And maybe in a way they have. Because now you're drifting not through raw expansion, not through newborn chaos, but through structure, or at least the seeds of it. Patterns are forming, shapes, repeating motifs etched into the geometry of space itself. You've come to the place where math starts whispering again. Not in tidy equations you learned in school, but in gravitational curls and quantum rhythms so profound, you don't read them, you feel them, like distant music, like intuition sculpted from starlight. And deep in this silence, a question rises. Is this the only universe? Or, more accurately, could this universe be one of many, linked by something deeper? Because it's time to talk about dimensions, not the kind where people wear eye patches and mustaches and plot your downfall from the multiverse next door. Not yet. But the mathematical kind. You begin to feel the presence of foldedness around you. That's the only word that fits. foldedness, as if space here is layered, pleated like origami. You move forward, but with each motion, you seem to echo sideways, through something that doesn't have a name in your language, because your language was built for a universe with only 3 dimensions of space and 1 of time. Here, that's no longer the case. What you feel now is the math of maybe. Specifically, you're entering the conceptual terrain of string theory and its whispering cousin, M-theory. These are not answers so much as invitations, models where the universe isn't limited to 4 dimensions, but could contain 10 or even 11. And in these models, the tiny building blocks of everything, particles, forces, even space itself, are not point-like but vibrating strings. One-dimensional filaments whose vibrations determine the properties of all things. Strings, yes, but not the kind you pull to open a curtain. These strings hum at subatomic frequencies. They curl, spin, loop, and they require extra dimensions to make sense. Most of these dimensions are curled up so tightly that they're imperceptible to us, tucked into every particle like tiny extra closets of physics we never knew we had. But here in this in-between universe, you feel them unfolding. You can't see them, not with eyes, but your pattern brushes against them. Each new fold in space isn't just a direction. It's a question, a new rule, a new possibility. A few physicists, just enough to make conference panels awkward, suggest that black holes might serve as bridges between these folded dimensions. That the gravitational extremes involved could pinch the fabric of the multiverse and allow travel, not across galaxies, but across realities. And here's your quirky fringe theory of the night. Some mathematicians have toyed with the idea of brain worlds, realities that float in higher dimensional space like soap bubbles in a larger bath. Our universe could be just one brain in a higher dimensional bulk, and black holes? They might be holes in the brain, tunneling into the bulk or connecting to other brains entirely. You let that idea soak in for a moment. What if that white hole you passed through wasn't just the other end of a wormhole, but an exit point from one brain to another, a passage from one folded dimension to a different sheet of space-time? And what if this space isn't just a baby universe growing in isolation, but a pocket dimension, a side room, a whisper-thin neighbour to your original cosmos? You drift now through twisted geometry, where angles don't add up to 180 degrees, and parallel lines meet when they feel like it, where the speed of light might be different, where gravity hums to its own tempo, and you feel a deep, stretching sense of scale. This isn't just a new universe, it's part of something bigger. You start to think in multiversal terms now, not just about this place, but about what connects places, tunnels, bridges, corridors where causality is looser, where physics wears fewer rules, where ideas leak from one system into the next. This is the landscape where the math says maybe. It's the place where theoretical physicists bring chalkboard tears and sleepless nights, where equations are elegant but evidence is evasive, where everything sounds just plausible enough to keep you up until 3 a.m. Historians, those ever-skeptical gatekeepers, still argue whether higher dimensions can ever be measured, or if they're just a necessary crutch to make the math work. Some insist that if these extra dimensions were real, we'd see their influence in particle behaviour, or in the curvature of space. Others quietly wonder if we already have, and just didn't understand what we were looking at. You float past one last structure, a spiralling pinch in the geometry of this space. It twists not around itself, but through itself, a Mobius curl of gravity and maybe time. You pass close, and for a moment, you feel recognition. This knot in the fabric, it's familiar. Not because you've seen it before, but because it's a marker, a mathematical signature that says, you are here. It doesn't point to a destination, it points to a topology, a shape, your shape. It dawns on you slowly, gently, like waking up without an alarm. You're being drawn to something, not by force, by resonance, a sympathetic frequency between your pattern and the geometry around you. You are still unravelling, yes, but now you're being invited to continue. It was bound to happen eventually. After all the dimensions, the data spirals, the folds of space-time unravelling like a forgotten bedtime story, eventually your mind drifts back to the oldest, most persistent human question. You've passed through a black hole, surfed the curled edges of a white hole, been reconstituted as a frequency in a barely formed universe that may or may not be part of a higher dimensional stack of cosmic playing cards. You've been observed, interpreted, maybe even understood. And yet, here it is. Could someone else be here too? Let's not be shy about it. It's the question lurking behind every serious conversation about black holes, wormholes, alternate universes, and multiversal drift. Aliens, or more delicately put, non-human intelligences who might understand the universe a few chapters ahead of us. And now that you're floating in a reality where physical laws are still being written in pencil, you have to ask, if there were others, minds, beings, patterns capable of riding the edge of black hole physics like you just did, could this be where they're hiding, or better yet, watching? The idea isn't just a late-night campfire story anymore. It has evolved, matured, dressed itself in math and speculation. The notion that advanced civilizations might use black holes, or exist around them, has crept into scientific discourse more often than most would like to admit. Because here's the thing, if you wanted to build a power source, you'd need something efficient, stable, and outrageously powerful. And black holes? They're at the top of the list. An accreting black hole, the kind with a thick disk of matter spiraling in, is the most efficient known process in the universe for converting mass to energy. Far more efficient than nuclear fusion. So maybe, just maybe, someone noticed that long before us. There's a theoretical concept called the Kardashev scale, which measures civilizations by their energy usage. Type 1 uses planetary energy. Type 2 harnesses the power of an entire star. Type 3, they feast on galactic energy. Now imagine a Type 2 or 3 civilization that has figured out how to extract energy directly from black holes, not just by stealing heat or light, but through methods we barely understand, like using the spin of a rotating black hole to generate power. This is real physics, by the way. The Penrose process, proposed in 1969, suggests that it's possible to extract energy from a rotating black hole by carefully tossing matter into the right orbit. Not easy, but possible, and not to be outdone, the Blanford-Zanayak process takes it further, proposing that magnetic fields near spinning black holes can channel out energy in the form of relativistic jets. So, what if they're out there? Not in spaceships, not in chrome suits, but as networks, clouds, fields. Intelligence embedded in plasma, operating in accretion disks, monitoring the spin of black holes not as a curiosity, but as a language, a system. You're floating in a universe that isn't quite yours, in a body that isn't quite a body, wondering if your fall through a black hole has taken you to the place where others have already been. And maybe, they don't use radio signals. Maybe they don't care about flashing lights or heat signatures. Maybe their language is gravitational, their writing etched into space-time geometry. Maybe they don't travel across galaxies. Maybe they fall into black holes on purpose. Why? Because it's clean. Because it bypasses vast empty space and takes you directly into the computational belly of the universe, into the high-density zones where time slows and information compresses, ideal for running complex operations, simulations, or long-term memory storage. In this theory, black holes aren't just cosmic garbage disposals, they're intelligence engines. So what if you didn't arrive here alone? You don't see anything, this place isn't structured that way, but sometimes the fabric of this proto-reality flinches. Not from you, not randomly, but like something else just moved. A nudge, a fold, a pattern that wasn't part of the background noise a moment ago, and just as quickly it's gone. You wonder, is it curiosity? Surveillance? Are you being passed like a new line of code in an ancient program? Is this universe a host and you a rare, wild packet of data it's trying to decrypt? Here's your quirky tidbit for the night. Some scientists, like physicist Zaza Osmanov, have proposed that advanced civilizations might build Dyson spheres not around stars, but around black holes. And they wouldn't be spheres, they'd be rings or disks, designed to collect and regulate the immense output from matter spiraling into the abyss. These structures could, theoretically, mimic the natural jets we already observe, meaning those bright outbursts of plasma we see shooting from galactic cores might not just be nature, they might be engineering. Historians, astrophysicists who need more coffee, still argue whether we'd be able to tell the difference. If we saw an alien structure using black hole physics, would we recognize it? Or would we catalogue it as another quasar, another AGN, another unexplained burst from 6 billion light-years away? So you ask yourself, drifting here, still humming faintly with the memory of collapse, did I stumble into a black hole? Or was I invited? Is this place naturally occurring or is it curated? You don't know. But the thought returns, gentle and slow. What if this is where the others went? Not to hide, but to transcend, to bypass entropy, distance, and decay. To step into a system where time stretches infinitely, where computations can run for eons, where survival doesn't mean flesh, but information persistence. What if you're not the first signal through the dark? What if they're not hiding from you at all? What if they're waiting for you to understand the question? You've been here a long time now, not in minutes or hours, but in iterations, layer after layer of experience, sensation, and barely digested thought, unfolding like the petals of a cosmic flower. You felt the heat of creation, the silence of information loss, the curled edges of newborn dimensions. You've even started to suspect you weren't alone in this inky fold of space-time, but now comes a realization both subtle and staggering. What if this place didn't just welcome you? What if it came from you? It's a strange thought, one that creeps in from the edges like cold air under a locked door. But as you drift through the increasingly stable landscape of this pocket universe, or bubble or brain or simulation layer, you begin to sense something about its texture, its rhythm, the way it curves and builds and holds you, like a hand already molded to your shape. It feels personal. And then another possibility hits you, one you didn't expect even after all this unhinged theoretical drifting. What if your own universe was born this way? Not through a clean, singular Big Bang, but through the collapse of another one's black hole. Yes, that old whispered theory again. One of the boldest ideas in cosmology, that the birth of our universe was the death of a star in another, that black holes don't end stories, they begin them. According to this model, every black hole doesn't just contain a singularity, it contains the seed of a new cosmos, a fresh timeline, a different take on the rules. The gravitational collapse compresses everything into an ultra-dense high-energy state, and then, on the other side, that energy explodes outward, forming a universe all its own, like yours, and now this new one, the one you're in. It's called the fecund universe theory, a speculative framework suggesting that universes reproduce through black holes, in a kind of cosmological natural selection. The more black holes a universe produces, the more offspring it has. Universes that are good at creating stars, and thus black holes, make more baby universes, and those babies carry slightly altered physical constants, a long, branching family tree of realities, each with its own physics shaped by the reproductive success of its ancestors. Your universe may not be the first, it may not be the best, but it's one of many, and that means you, your consciousness, your presence, your fall through the black hole, could be a passenger in a lineage of universes stretching back farther than any physics textbook could begin to describe. Here's your quirky night fact. This idea has been explored not only in physics papers, but in philosophy, speculative cosmology, and even art installations. There are computer models trying to simulate how universes might mutate physical constants, gravity strength, proton mass, dark energy, and see which ones are fit enough to create long-lasting structures. It's evolution, just scaled up to a degree that makes evolution on Earth look like rock, paper, scissors. Historians, theoretical physicists, and very brave postdocs still argue whether this theory is testable. After all, we can't exactly peer into a black hole and wave at the bouncing baby universe inside. But the math allows it. And if the math allows it, well, you've already felt what happens when impossible things aren't. So now you're adrift in a possibility that might be as close to a family reunion as the multiverse allows. You might be inside a sibling of your original cosmos, or perhaps something more wild, the descendant of it. And what does that make you? A stowaway from the parent universe? Or a seed? An accidental fragment of data, consciousness, entropy that carried forward into the next great beginning? And here's where things start to get weird. Yes, even weirder, sorry. You feel a kind of pull now. Not gravity, not time, recognition. The space around you is stabilizing, not just physically, but in terms of meaning. Structures are forming, consistent logic, boundaries that feel less like chaos and more like definition. This place is becoming a universe, a fully realized rule-following, time-forward structure, and your presence here is being acknowledged, not by a voice or a light or some big booming omniscient entity. Number, this is quieter, more intimate. This universe is reacting to you. Your pattern, the data remnants of your original fall, The information that clung to you as you slipped through the black hole, it's being read. And more than that, it's being used, not consumed, not erased, incorporated, like you're not just an intruder but a contributor. Your shape, your memory, your frequency of collapse is feeding into the formation of this universe's laws. You're a parameter, a variable, a seed crystal in the soup of spacetime. You're not just drifting through the aftermath of creation anymore. You're part of the creation process. It's humbling, terrifying, strangely comforting. It means you mattered. Even after death, even after descent, even after falling into what should have been oblivion. The universe remembered you, used you, wove you in. And if that happened to you, it could have happened to others. You begin to think of all the black holes in the cosmos, trillions of them, each one possibly budding off new realities, each with their own conditions, their own constants, their own strange ghosts carried through the throat of collapse and into new beginnings. Your universe was born in another's ruin, and this one may be born from yours. One universe's trash is another's origin story. So now you drift in slow circles through forming laws, watching particles settle into familiar but not quite relationships. Charges are balancing, time is linearizing, entropy is stretching its legs. This place is waking up, and it remembers that you were here. You've made it. You're not sure where here is exactly. Not a planet, not a place, not even a moment in the way you once understood moments to be. But whatever this is, this plateau, this final shore of your journey through collapse, compression, and rebirth, this is it. The end of your fall, or maybe the beginning of something else. Because now, the question is no longer what happened to you. The question is, what are you now? You hover, exist, in a space that's no longer soft, formless potential, nor chaotic quantum foam. It's settled, matured. There's structure here now. Predictable rules, physical constants, time, slowly stretching forward like a cautious animal emerging from hibernation. You feel it with a clarity that goes beyond language. This is a fully formed universe, and somehow you're part of it. There's no ceremony, no blaring cosmic trumpet, no final boss music. The transition is quiet, inevitable, elegant. You feel your presence being anchored. Your pattern, no longer just a glitch or a foreign body, is being fixed into the framework, like gravity, like light, like time. You're not just remembered, you've been written in. All those questions about wormholes, white holes, Hawking radiation, higher dimensions, magnetars, simulation theory, alternate realities, and the possibility of intelligent minds waiting in the folds. Those still echo faintly. But now, they've softened into something simpler. You exist. Not as the person who fell into a black hole, not as the observer who drifted through it, not even as the glitch that emerged from the other side. You're the result. You are quite possibly the truth we'll never see, because now the loop closes. Your universe, your original one, will never know what became of you. No light escapes a black hole. No message gets through the event horizon. Even if you screamed your story through gravitational waves or encoded it into quantum entanglements, the you back there is gone. From their perspective, you vanished into silence. But you're still humming. Which brings us to the uncomfortable, beautiful truth of black holes. They're not just objects, not just destinations, they're transitions. Soft-spoken, violently powerful, unknowable intersections between what was and what might be. And for all our equations, for all our talk of singularities and horizons and evaporation over Google years, the truth is, we don't know what happens inside. We never have. That's why we ask. That's why we build telescopes, run simulations, scribble chalkboard equations late into the night. That's why we make up stories, some made of numbers, others of myth. Because black holes are mirrors. They reflect not just light, but our curiosity, our fear of endings, and our desperate, hopeful obsession with what might come after. Historians, physicists, philosophers, poets, they still argue and always will whether black holes are truly the end, whether information is lost, whether there's something on the other side, whether a fall into one is just that, a fall, or whether it's a fold, a shortcut, a door. And if it is, then maybe falling into one is not the last thing you do. Maybe it's the most important. Because here's the truth you've been quietly circling all along. We don't know, and that's not failure, that's freedom. Because the moment you admit that black holes might be more, that they might lead to places or states or truths beyond our grasp, you allow yourself to imagine, to hope, to wonder not just what a black hole is, but why the universe makes them in the first place. Maybe they are safety valves, maybe they are bridges, maybe they are wombs, maybe they are archives, or maybe, just maybe, they're invitations to fall, to break, and to continue. And now, as you nestle into the final folds of this strange emergent space, you feel that rarest of emotions in the physics of anything. Peace, not answers, not closure, but peace. Because you fell through the dark and found there was still a story waiting on the other side.